All right, well, thanks again for your attendance. As Chris introduced me, I'm Ritchie Green, the Health and Safety Director for Bouygues Construction Australia. Prepared to present a webinar this morning in respect to mobile plant tech and innovation. Bouygues Construction is a part of a group of companies. At the top level, we're employing circa 32,000 employees, operating across 60 countries worldwide with an annual turnover in 2022 of 13.2 billion euro. In terms of the local subsidiary, Bouygues Construction Australia, we've had a 25-year presence in Australia, having delivered such projects as the Sydney Airport Rail Link, which was delivered in joint venture back pre-2000, North Strathfield Underpass, the Go-Between Bridge in Brisbane, the North Connects project through a JV partnership, West Connects 3A, and most recently the Melbourne Metro project through our participation in the Cross Yarra partnership. So in terms of the OFSC accreditation scheme, there's been 346 mobile plant related incidents reported to OFSC over the last 3 years. Unfortunately, 3 of these were fatalities, with 2 occurring in 2022. 198 or 57.2% of these incidents resulted in a severity of a lost time injury, which is quite significant. 40% of the incidents reported occurred due to plant striking an object or person. So plant are certainly quite prevalent in terms of incidents being reported by scheme accredited contractors to the OFSC. In terms of OFSC project audits, there's been 452 conducted in 2021. In terms of the breakdown across the scheme criterion, if we look at hazard criterion 16, mobile plant and equipment, there's been 686 cars issued, which equates for 18.6% of all cars issued by OFSC. So the single largest contributor for corrective actions issued is mobile plant and equipment H16. If we look at the breakdown of H16, if we look at the top 3 contributors, again, 16.3 resulted in a car rate of 35.8%, 16.9 a car rate of 33.2%, and 16.10 a car rate of 28.2%. 16.3, as most of you are aware, relates to safe systems of plant for the provision and operation of mobile plant. 16.9 is inspection and maintenance, and 16.10 focused on preventative maintenance. I would say from experience, if you're having difficulty demonstrating compliance with 16.9, most probably you're going to be distressed with criterion 16.10 because the 2 are quite closely related. In terms of the Bouygues Construction Australia safety program, and I suppose a bit of context as to why I'm presenting today is, in terms of our safety program, six key pillars: company safety standards, safety leadership, critical incidents, risk management, system simplification, and in particular, tech and innovation. So just to talk you through a few practical examples of technology innovation as being applied by BYCA. BIM modelling is obviously, that's more customary practice in the industry, but the BIM modelling leading into the use of digital twins throughout the design phase to create a virtual environment of the project design that can be tested for space proofing, can be tested to ensure that we're aligned with all of our health and safety requirements. And our methods planning process. The methods planning process is unique to Bouygues. It's a process where we utilise 4D CAD software to pictorially illustrate each step in the construction sequence of all high-risk activities. These methods drawings are then collated and they're presented in what we call a critical risk review session, where they're peer-reviewed by discipline leads and other project leaders. Now, the methods drawings enable us to pictorially represent all of our company safety standards or critical risk controls. It allows us, again, through that peer review process, to test the space proofing, the plant people separation, pertinent or critical risk controls relating to cranes and lifting or temporary works, as an example. Proximity detection systems. I want to speak to 2 particular incidents which occurred across our operations. One on the North Connects project, which occurred back on the 20th of Jan 2017. we had a gantry crane impact the jib of a crawler crane. So a crawler crane was mobilised into the shaft enclosure building on this particular site of Wilson Road due to the productivity rates with the gantry crane, obviously working in very close proximity and interfacing with the gantry crane. At this particular occasion, the mobile crane had slewed around, and unbeknown to the gantry crane operator, who then tried to traverse the gantry crane, had actually struck and made contact with the jib of the mobile crane. On this particular occasion, we'd actually retrofit the strata system, which was a proximity detection system, to the gantry crane. So what it actually did was alert the operator, and being an active system, it not only alerted the operator to the presence of the boom of the mobile crane, but it actually overrode the power system of the gantry crane and brought it to a standstill in the process as it made contact with the mobile crane. What was significant on this particular occasion was there was two workers working from a crane workbox suspended circa 100 metres above the invert level of the tunnel, above the shaft at that particular site. So it had potential to be a catastrophic event. Was averted through the application of the proximity detection system strata on the NorthConnex project, albeit it was rolled out to all the large-scale, high-volume plant within the tunnel environment, retrofitting it on the gantry crane, albeit not the intended application when we instituted this particular system. I can definitely attest to the fact that that prevented a catastrophic event. A second example where we've applied or deployed proximity detection was an incident I'll touch on back in 2019 at the SBI site within the WestConnex 3A project, where we had a front-end loader was loading our tunnel spoil from the M190 portal into the back of an articulated dump truck. In the process of reversing, the loader struck the basket of a stationary EWP with a worker in the basket. So the EWP traversed again behind the front-end loader into its blind spot, unbeknown to the operator. Although the operator immediately applied the brakes in response activation of the proximity detection system, which was the black stair system on WestConnex 3A, the loader still contacted the EWP, causing damage to the basket. However, a more significant consequence was prevented. So I've got the graphics there illustrate the particular incident in question, depicting the loader and the EWP up on the top left. The top right depicts the damage to the basket of the EWP, and the bottom picture there is actually a still taken from the black stair. So the black stair system obviously enables the diagnostics post-incident as an added value of actually deploying the system. And that still, if I can just hit play, it's actually captured from the actual black stair camera itself. And I've got a short video clip I can quickly play you, which actually depicts the actual incident event. It's albeit very instantaneous. That's taken from the actual black stair camera. So I can attest to both of those incidents have certainly prevented, or both of those occurrences, we prevented a more critical event through our deployment of a proximity detection system. NorthConnex, again, was a strata system, which was an active system. So the way that works, there's an outer threshold, detects the presence of a pedestrian. It alerts the operator, which is typically it's a 10 to 12 metre zone. If the pedestrian continues to encroach closer to the item of plant, to the inner threshold, which is circa 6 to 8 metres, as an active system, it actually overrides the power system of the plant and slows the plant down to a walking speed. Black stair, it's a passive system, it's not an active system, and it relies upon the use of sensors to continuously scan the blind areas around plant and reconstruct a 3D environment. The identification and nature of each obstacle is based on video recognition algorithms developed by the French Atomic Energy Commission, used to alert the plant operator of the presence of a pedestrian or a worker. And the graphic there in the middle, in the lower portion of the slide, actually depicts the screen, which will be viewed by the operator of the plant. So obviously in green denotes that it's clear the cameras have not identified, or the black stair system has not identified the presence of a worker. With the algorithm in the left-hand picture there, it's identified the form of the human body or a worker, and it basically activates the alarm and the flashing red symbol on the panel, which is viewed by the operator within the cabin. Okay, so in terms of a net safety benefit, I think we could clearly attest that the deployment of proximity detection systems on both WestConnex 3A and the NorthConnex project, again, have prevented a critical event, possibly having potential result in a fatal incident. As another example of plant innovation is the Brook tool. The Brook tool is a remotely operated plant removing people from dangerous or repetitive tasks. The Brook tool is an example of innovation whereby the excavator is remotely controlled, eliminating the need for a plant operator. In terms of a net safety benefit, there's a reduced worker exposure to respirable crystalline silica and the risks associated with unsupported ground. Through our deployment, we've also demonstrated we've met our productivity objectives by deploying this particular innovation. We can report an increase in productivity, also a decrease in breakdowns and downtime with mobile plant. So again, it's a good example where we've aligned our safety objectives with our productivity objectives, and the two have been integrated, and certainly we've delivered on a positive safety outcome. In terms of further innovations, the ASB JV and the WestConnex 3.0 project utilise an inflatable brattices as an innovation to reduce RCS exposure. Inflating the brattice is a simple and safe method to seal the working area in the tunnel environment. And in particular, it prevents the recirculation of dirty air, pushing RCS contaminated air into other areas or zones within the tunnel. As a consequence, we're also able to reduce work at height. The brattice can be installed in 30 minutes, so it's quick and it's effective, it's reusable. And in terms of change management, the quick installation achieves dust separation compartmentalisation, and it has application in cross passages as well, again to prevent the contaminated air pushing out from the CPs into the tunnel drives. Very simple, practicable, achievable, certainly delivers a net safety benefit in that it prevents the recirculation of dirty or contaminated air. Another example on the WestConnex 3.0 project was the fob system. The fob system was developed in partnership by the ASB joint venture, GB Auto and Interfleet IVMS system. The hardware linked with the Pegasus system to track, which was used to track operator competency, and in particular the status of the high-risk work licenses, VOCs, and their authority to operate. The technology utilises underground Wi-Fi and functions offline. Operators simply tap their Pegasus card on the fob hardwired panel of the plant prior to activating the ignition. Any unauthorised plant movement activates the flashing the headlights and blasts the horn. It can be used to override to prevent the actual plant being operated, but the ASB JV elected to enable the operator to operate the plant to cater for any particular emergency situation, albeit it activated, as I said, the flashing light and the horn to alert the adjacent construction workforce as well as the supervisor that an unauthorised person was operating the plant. The experience on WestConnex 3.0 was implemented on 120 items of plant, including 42 dump trucks, excavators, skid steer loaders, wheel loaders and telehandlers, and it represented a circa 850k investment. Now I'll just attempt to play for you a quick audio reel to show you when an unauthorised operator jumped into the plant as to how it activated the horn and the flashing light. That would certainly grab the attention of the adjacent supervisory team on site and again alert the ASB JV to the fact there was an unauthorised person who had not received an authority to operate. Quite an innovative piece of technology. Other examples of plant innovation were the Halo system, which again is more customary practice out in industry. We had a very good experience adopting that particular technology on the WestConnex project, as well as the use of presence sensing systems in the cross passages. So obviously with the CPs, they're narrower. It's very difficult to locate a hard barrier as people plant separation as required by the project GMR safety standards. So what we did, we deployed the presence sensing system, which provided a visual line of where was a safe location for the pedestrian or worker to travel or walk through the particular cross passage. But the presence sensing functionality would actually instigate an alarm and a flashing red light at either end of the CP, alerting any operator of mobile plant on approach to the cross passage that there was a worker in the immediate vicinity on foot, possibly in a blind spot just behind the intersection of the cross passage. So quite an innovative piece of technology. The rotating lifting tool was another innovation. It was designed by the ASB JV on the WestConnex 3.0 project. It was actually used due to the height restrictions at the site. The panels are delivered on their side and with the ultimate need to rotate them 90 degrees to be able to locate them into their installed or design position. Typically, this task is completed via a dual crane lift, which, as most of you are aware, is a highly hazardous process. where one crane is used for the main lift and the second crane to maintain the precast panel at its base. The primary risk of performing a dual crane lift is the potential to overload the crane and or overturn the Frenner crane. To improve safety and efficiency, following successful trials with a precast supply, the rotating tool was successfully implemented, eliminating the dual crane lifts for this particular activity. And you can see the graphics there illustrate the sequence whereby the precast panels would arrive on site in a horizontal plane within the basket or stillage. They would be lifted then by the crane with the two lifting lugs on the longitudinal edge of the precast panel. Individual panels would then be moved and located on the lifting tool, whereby it was in a stable position, which enabled the double-legged chain sling to be detached and reconnected to the two lifting lugs at the top edge of the panel. Then by use, I should say, of the lifting tool in a very controlled and planned manner, the panel could be moved from its horizontal position up into a vertical plane, where ultimately it'd be located into its designed or installed position. So again, quite innovative, and again, a very controlled process to actually locate the precast panels via the use of the lifting tool. Another lifting tool which was developed on the WestConnex 3A project was for use with a long egress passage precast sections due to the height limitations within the tunnel drives, where the precast units would have been rotated from the horizontal again to a vertical plane on site using a dual hook setup. This system was relying upon the use of a spreader bar to lift each unit, whilst the LEP, the long egress passage precast unit, was modified to allow an engineered tailing beam to be temporarily installed at the bottom of each unit, with the attached rigging could be linked to an additional sheave. In terms of a net safety benefit, to improve safety and efficiency, trials with the supplier of the precast panels was undertaken, and ultimately substitution of the work method in terms of the hierarchy of risk controller was risk substitution, but ultimately eliminated the risk of a dual crane lift, hence eliminating the risk of crane overturning and or a loss of control of the load. In terms of its application on the WestConnex project, it was utilised for the lifting and transfer of 675 units, installed weighing circa 7.5 tonnes by use of a 40-tonne Frenner crane, saving circa 100k AUD on crane hire. So again, it was a good example where we're able to align the safety objectives of the project with our financial and program objectives. And again, I'll just play a short video clip for you. Again, very simple, but innovative and certainly highly effective. And you could see from that video clip, the long egress passage precast units were alternated from a vertical plane to horizontal, which enabled them to be traversed in a very safe method through the tunnel drives, where they're restrained by the system. And that enabled also to, in the horizontal plane, the Frenner crane operator to lower the boom as low as reasonably practicable whilst traversing through the tunnel drives. And then in a very controlled manner, they were moved back into a vertical plane, back into their designed or located position. Mechanical arm, that was another initiative of the WestConnex 3A project, where initially we would be relying upon having a young, typically a graduate engineer or a construction worker up at height on the mobile scaffold to sample the concrete which was being delivered for the continuous reinforced paving via the tipper trucks. Testing was being undertaken at height, as well as exposing that particular operative to a risk of falling into or becoming involved in the back of the tipper truck. The ASB BJV went away and undertook a study of that particular activity, and they developed an initiative which was the mechanical arm, which ultimately was used as a substitute for the concrete testing being performed, again by a young graduate engineer or a CW, manually at height on top of the scaffold. So again, quite effective and is a very good example of where, again, I would integrate our safety objectives with the program objectives of the project. Net safety benefit was clearly realised because we eliminated the worker at height, sampling or undertaking the testing. In terms of the sampling process, we were able to improve the cycle time efficiency. So it was 15 minutes reduced to 4 minutes. And in terms of a value proposition, the number of testers required reduced, leading to a $600 saving per shift. So again, through a mega project like WestConnex 3A, delivered over a circa 4-year contract duration, that led to a fairly significant saving, as well as demonstrating our safety values and safety innovation. Talia was a TBM simulator. This is Bouygues Construction patented technology, which was deployed on the Melbourne Metro project and adopted by the Cross Yarra Partnership. Through the TBM simulator, we're able to run TBM pilots or TBM pilot trainees through a number of scenarios where we depict 15 critical high-risk scenarios associated with TBM operation, including tunnelling through ground faults, poor ground conditions, and over-excavation. The use of Talia is guaranteed safe program delivery for the tunnelling works on the Melbourne Metro project, significantly diminishing tunnelling risk through its delivery. Evaluation of success, CYP utilised Talia to train upskill 6 TBM pilots, fostering local skills development, leaving a lasting legacy for the Victorian construction industry. We get a very good example by CYP's adoption of the simulator in terms of delivering a net safety benefit to the project and the Victorian construction industry more broadly. Camera AI system. So on the WestConnex project, again, to increase the crane operator's situational awareness, giving them eyes on the hook. The WestConnex project implemented the Apollo M1 camera technology, guaranteeing safe crane and lifting operations by providing real-time visual of the crane hook and lift, providing the crane-appointed person remote visibility and transparency of critical crane lifts, anticipating safety risks arising from any environmental factor or unsafe load configuration in real time. And it also enabled the team to undertake diagnostics, providing operational data for analysis of individual crane lifts. Okay, pile cap removal. This was really an innovation deployed as a part of the work method utilised for the break back process with piling operations on the Melbourne Metro project by the Cross Yarra Partnership. The method involved a chemical system where, by the use of an expanding mortar, to create pressure and generate a perfectly horizontal cut. So the top layer of the concrete in the pile can be easily removed by a crane. In terms of a net safety benefit, the methodology eliminated the need to use jackhammers and excavators in the pile breakback process, reducing noise, dust and vibration. The use of mobile plant for the task was also eliminated, diminishing the plant-people interface risk being the most significant net safety benefit realised by deploying this particular methodology of utilising the expanding mortar. Virtual superintendents and IVMS system, an in-vehicle monitoring system. It was a system deployed on the NorthConnex project as well as the WestConnex 3A project. It's a 2-user-based vehicle monitoring system that tracks heavy vehicles in real time, monitoring speed, fatigue, vehicle routes, and other heavy vehicle driving events. The system collects live monitoring data and uploads to a web-based and mobile app, facilitating the management of heavy vehicle compliance in respect to chain of responsibility obligations under heavy vehicle national law. Virtual Super also allows drivers to conduct various COR checks that they sign on and off when using the mobile app known as SafeSight. So very effective in terms of its ability also to monitor fatigue, and again having a demonstrated application on both the NorthConnex and the WestConnex 3A projects. The PBV system utilises emergency response system. The PPE Vantage software deployed by WestConnex provided a centralised navigation interface, enabling intelligent control, monitoring and reporting. The integrated system tracks and monitors all worker and mobile plant movements from a single platform, providing assurance regarding their known location. In terms of net safety benefit, it enabled real-time monitoring of workers exiting the tunnel during an emergency situation. It provided critical data regarding plant-people interface for diagnostics, and also has an application for the monitoring of lone workers. So again, quite successfully deployed on the WestConnex 3A project. The Seeing Eye machines is something at the back end of WestConnex. There was a trial run, albeit a very light trial, to monitor the Seeing Eye machines. It's probably more a blue sky initiative for us, which we continue to research and undertake some analysis on for a potential deployment on the next major project. The seeing machines is utilised to monitor fatigue. And it monitors fatigue where an event is triggered with the operator's eyes closed slow enough not to be a blink, and the eye closure lasts longer than a configured threshold. The vehicle must be travelling at or above a configured speed at the start of the event. There's a detection criterion which the system utilises to monitor eye closure, where it's measured as eyes where your eyes are closed more than the 75% threshold. The default eye closure duration threshold is 1.5 seconds. In terms of system functionality, it detects fatigue through eye closure, detects distraction through head movement. The minimum vehicle speed for the event must be set. It runs or pushes notifications as a part of in-cabin alerts, audio and vibration, data transmission running off 3 and 4G, and software version updates over the air. So again, we ran a albeit a light trial at the end of the WestConnect 3A project, but as a part of something that's a bit more probably blue sky for us, something we're certainly looking more closely at for future deployment. And again, it's technology that's been deployed in the mining sector and also across the heavy vehicle and logistics sectors elsewhere in Australia. Our global safety essentials, this is very nuanced towards Bouygues Construction Australia, but all of our health and safety performance standards for the management of our 12 critical risks, we known as our GSCs, are published within an app on both the Apple Store for the Apple phones and, of course, for the Android phones on Google Play. So the QR codes are there. They're the critical performance standards we rely upon for the management of all the critical risks across our operations, from work at heights, mobile plant, cranes and lifting, temp works as an example. And we've also got 2 GSCs nuanced towards tunnelling activity, GSC 8 and GSC 9 for compressed air tunnelling. They're publicly available. They're published on Google Play and Apple, and you're welcome to download a copy. All right, Chris, that brings me to the end of the presentation. I'm happy to throw back to yourself and a bit of a segue in for Brett Jones, and happy to take questions at the end of the presentation.